Hi, this is Group 23's Senior Design video. Our sponsor was the UConn Department of Kinesiology, and we worked with Professor Stephen Harrison. The problem he was looking to solve was firefighter navigation in a smoke-filled building. When a firefighter enters a burning building, one of the biggest challenges is getting back out again. Rooms filled with smoke make you functionally blind to your environment, which limits you to your sense of touch for navigation. This is inefficient and dangerous. A possible solution Professor Harrison is researching is a sensory biofeedback system. This would be a wearable system that would give tactile feedback in order to help navigate. It would utilize 3D mapping and navigational hardware in order to create a sort of digital breadcrumb path that a firefighter could follow to exit the building. The breadcrumb system works because of three main parts: the attitude and heading reference system, which measures which way you're facing, the ultra-wideband radio network, which measures your coordinates, and the belt array of tactor motors, which directs you where to go. As the user makes their way through the environment, they place down breadcrumbs, which act as markers to the system to retrace your steps. The belt array of tactors always vibrate in the direction of your previous breadcrumb, which allows you to backtrack to where you used to be. Our task was building a software program that could be used for researching and testing this solution. Our first goal was to make sure that future development and use would be easy. This was because the end users would be researchers who would most likely not have computer science backgrounds. Our second goal was to make the program hardware agnostic. This was because future users may want to use different hardware than what we have available today. Because of these two goals, we divide the system into two main parts: algorithms and I/O processors. These abstractions are separate executables that communicate to each other over a shared TCP protocol. The I/O processors are hardware specific, with one needing to be written for each piece of hardware attached to the system, while the algorithms are hardware agnostic. Once you write one, as long as you feed it data it can understand, it will work with any piece of hardware. The I/O processors create a sort of black box where the algorithm only sees the output and doesn't have to worry about the hardware. One of the challenges we faced was pinpointing our main task. We had difficulty narrowing down what our client wanted and went through a couple different iterations. Another hurdle that we had to get over was that our client wanted the system written in C++, as it was the language he was familiar with. We as a group had a very limited knowledge of C++ and had to spend some time learning a new language. On top of this, there was also faulty hardware and the quarantine due to COVID-19, so it was a lot harder to make progress near the end of the semester. Although we didn't finish the breadcrumbs implementation, we did complete the software backbone on which future implementations can be built on top of. In the end, the project was a valuable learning experience for all of us. We just hope our client is as happy with the results as we are. Thank you for your time and support.